Hello chickadees. Today our objective will be to determine the mean absolute deviation and use it to describe a set of data. Now, I know you're probably thinking, mean absolute what? But I promise you it's a lot easier than what it sounds. Okay, let's first start by talking about our essential question. Now we're going to be building on the same question we've been thinking about throughout this unit. How are patterns used when comparing two quantities? Once again, our essential question is, how are patterns used when comparing two quantities? Okay, well, let's go back to our objective, mean absolute deviation. Well, what exactly is mean absolute deviation? Well, let's start off with a lovely definition. The mean absolute deviation of a set of data is simply the average distance that each value in our data is away from the mean. Once again, it's simply the average of the distance that each value is away from the mean. So we are going to figure out how we do this. It's super simple, I promise you. Okay, so let's say we're looking at some roller coasters, the speeds of the roller coasters at a park. We have roller coasters that go speeds of, let's say, 58 miles per hour, 88 miles per hour, 40 miles per hour, 60 miles per hour, 72 miles per hour, 66 miles per hour, 80 miles per hour, and 48 miles per hour. Now, I don't know about you, but that sounds a little fast for me. Anywho, let's first start by figuring out the mean of our data. Remember, to determine the mean, you simply add all the values together and then divide by the number of values in your set. When we add all of our values in our set together and divide by 8, the number that we have, we get an average of 64 miles per hour. Well, now that we know the mean, we are going to figure out how far each value in our set of data is away from that mean of 64. So step 2. Determine the absolute value of the differences between each value in the data set and the mean. Well, let's do a quick review. Absolute value. Remember, absolute value is simply the distance of a number from 0 on a number line. So if we're talking about the distance of a number from 0, we're always going to be working with positive numbers. So even if you do your subtraction and you get a negative number, for the absolute value, we are going to use its positive opposite. Okay, so now what I've done is I've taken each value from my data and found the difference between the value and the mean. Remember, the mean was 64. And then I used the absolute value of that. So 58 minus 64 gives me a negative 6, but since we're talking about absolute value, we are going to have a positive 6. Okay, 80 minus 64 is 16. The difference between 88 and 64 is 24. The difference between 40 and 64 is 24. The difference of 72 and 64 is 8. The difference of 48 and 64 is 16. And then the difference of 60 and 64 is 4. And last but not least, the difference between 66 and 64 is 2. And remember, since we're talking about the absolute value, all of these values are going to be positive. Okay, so quick review. Step 1 is to determine the mean of your data. Step 2 is to determine the absolute value of the difference between each value in your set and the mean. And then last but not least, step 3, determine the average of the absolute values of the differences between each value in the data set and the mean. In other words, we're taking all of those differences that we found and we're finding the average of those. So 24 plus 16 plus 6 plus 4 plus 2 plus 8 plus 16 plus 24, all divided by 8, gives me 12.5. So the mean absolute deviation of this set of data is 12.5. Well, what exactly does that mean? The mean absolute deviation is 12.5. This means that the average distance each data value is from the mean is 12.5 miles per hour. Well, why is this helpful? When you're looking at two sets of data, you can compare the mean absolute deviations for them, and the data set with the smaller mean absolute deviation has data values that are closer to the mean, while a data set with a greater mean absolute deviation has values that are further away from the mean. That is why we find the mean absolute deviation. It helps us to determine if the mean is useful. The further away the values are from the average, the less useful knowing the average is. When the mean absolute deviation is large, that means that the mean is not relevant. That's because there's an outlier. This example is coming from page 664 in your textbook. Okay, determine the mean absolute deviation for the set of data. Round to the nearest hundredth if necessary, then describe what the mean absolute deviation represents. Okay, so the first thing that I must do, step 1, is find the mean. And I do that by adding the values from my data, so 112 plus 145 plus 108 plus 160 plus 122, and then divide by the number of values I had, which was 5. And that gives me 129.4. So my data has an average of 129.4. So step 2, find the absolute value between the distance of each value in your data set and the mean. So we've got the absolute value of 112 minus 129.4, and that gives me 17.4. Then I have the absolute value of 145 minus 129.4, and that gives me 15.6. The absolute value of 108 minus 129.4, and I'm doing this on the calculator, so when you see my hand going to the side, that's what it's doing. 129.4, and that gives me 21.4. Then the absolute value of 160 minus 129.4, and that gives me 30.6. And then the absolute value of 122 minus 129.4, which is 7.4. So now for step 3, I'm going to take all of these distances, the absolute values between the values and the average, and I'm going to find the average of those distances. So I have 17.4 plus 15.6 plus 21.4 plus 30.6 plus 7.4, all divided by 5. And let's see what that gives us. That gave us an absolute deviation of 18.48. And so the average distance each value in our set of data is from the mean is 18.48 visitors. Now, for the moment you've all been waiting for, you get a chance to work it on your own. Now, I just did number 1 on page 664. So, for your secret question, you will be doing number 2 on that same page. The table below shows the height of water slides at 2 different water parks. Determine the mean absolute deviation for each set of data. Round to the nearest hundredth, then write a few sentences comparing their variation. Get up!